Hi, my name is Julio Rodriguez. I'm going to explain what happened when we select incorrectly the datum features, what is the impact, and why we should think about the function, how we stack up some tolerances. So let us start with this simple example with two components. Let us call them component number one, component number two. We have this situation, and for some reason, we are interested in getting the distance between these two components. So this distance is important. Let us imagine this is an electronic component. We have a gap in between the two of them to keep the safety of the components, electronic components. And this distance is important, and we are interested in computing that distance. Probably, if we do not think about the function, the more intuitive thing is to locate the parts something like this. Because we place it over the large surface, accessible surface, so it's very intuitive to do something like this. If we create a drawing with this setup, we will get something like this. Some dimensions and tolerances on the green surface. And with component number two, we probably will be doing a similar thing. So we place the part like this, and we end up dimensioning from that surface. So that's it. If we're looking for the distance x, we perform a very, very simple stack up analysis here. So it will be the green distance, this distance in green, minus the red distance, this distance in red, and that's it. In order to compute the maximum and the minimum x, we need to incorporate the tolerances. But here, in order to get this green distance, we need to use the two dimensions and the two tolerances because we don't have a direct dimension representing this green distance. So we need to subtract this distance minus this distance. Same like for the red distance, we need to subtract the two of them in order to get the distance we are looking for. So when we do the math and we compute the maximum distance x, we end up to get 2.8, and the minimum distance x, we get minus 0.8, which means we will get some interference, which is not a good news, because when we perform the assembly, we don't, basically we do not observe any interference, but it may happen with this drawing. We assemble the very, very worst case component one with the worst case with component two, we will get some interference, 0.8. So probably we need to come back and we need to reduce the tolerances, any of them or a few of them, or we need to change the design. The two of them, they cost money. They are not really, really good options. However, there is an alternative here. If we look at the function, the contact surfaces are these in green. If we dimension from those functional surfaces, we will end up with something like this. Please note, we are not changing any values for the tolerances. We are not changing the size of the components. They are the same components, the same tolerances. We are not changing anything. We are just changing the way we express these into the drawing. We are just changing the baseline that we are using as a datum, okay? So from this baseline in green and from this baseline in green with dimension, if we perform again the stack up analysis, we will get for the maximum a smaller variation than before, and for the minimum also a smaller variation. But the good news here is that we do not have any interference. So we do not need to do any redesign, or we do not need to reduce the tolerances and making the part more expensive. So I hope you find this example enlightening the topic. Another topic would be something like this, perpendicularity. Let us assume we want the perpendicularity of this element, cylindrical element. Probably the more intuitive thing to do is something like this, perpendicular to this surface. However, when we look at the assembly, we realize the contact is happening not on the bottom surface, but on this surface. This is the functional surface. So our drawing should be something like this, because when we do not do something like that, we are stacking up tolerances. This in CAD, we won't see any difference. In the model, in the CAD model, everything is like perfect. So there is really not a problem by using this surface or this surface. But in the reality, we may have something like this exaggerated error, like this one, and then probably this part will be rejected because this cylinder is not perpendicular to the datum in orange. So we reject this part. However, when we attempt to perform the assembly, the function, the part is good, the part is okay, because the cylinder is really perpendicular to the green surface, which is the functional surface, even though it's not perpendicular to the orange surface. But we do not care because we are not making any contact to that surface. So we don't care about it. So this is what happened when we select incorrect surfaces. We are stack up tolerance, we create more expensive parts, we create some problems for free, which is not a good idea. So that will be it for today. My name is Julio Rodriguez. You have a nice evening. Bye now.